Hello everybody. In today's video, we'll look at chapter 3, derivatives, from Thomas's calculus book. A link to this book will be in the comments below. So first we'll look at the definition. Definition is, we'll look at just this, this equation for now. This is, it says it's the gradient is m, as limit h is a small number, h as h tends to 0, f x 0 plus h minus f x 0 over h. Let's take a function of this nature. So this is our function, like you can say it's like f equals x squared, that is your function. And if we have a point here called x0 and we select another point h x0 plus h, the difference would be h units, and the value here would be f at x0. That's the y value. And the value here would be f x0 plus h. So what you're doing here is we are taking the distance here, which is f x0 plus h, and minus x0, that's the distance, and divided by this h. So that gives you the gradient of this. So this, it gives you this triangle, the gradient of this triangle. But what happens when h is equal to 0 and h tends to 0? What happens is this point collapses to this point. So if I may draw another another graph, when h tends to 0, x0 plus h x0 tends to this point, and when it tends to this point, the gradient is at the point. You get the gradient at the point. So as h tends to 0, what you do is get a gradient at the point of this line that I'm drawing. Now, if I draw a line combining through x0 and x0 plus h, this would be a line. It has to go through 2 points. So but this line, as h tends to 0, limit as h tends to 0, it touches only one line, so it becomes a tangent because it touches the point only at x0, the curve only at x0. So we say that this is a tangent, gradient of the tangent as h goes to 0 at x0. Gradient, the tangent of the curve, the red curve I've drawn here at x0. So the definition, there are some books that replace h by delta x. So this is also a definition, f x0 plus delta x minus f x0 over delta x. So what we do here is we first substitute x plus delta x in this equation to fx, right? Instead of x, you put delta x in the curve, and then you subtract fx. We say x0 or x, and then take limit as delta x goes to 0. That's what we do. So let's look at another question. So here we say fx is equal to x. So let's look at fx equals x. This is the curve fx equals x. This is x and this is the y-axis, and this is fx equals x. they want to derive the derivative of the function f(x) from the first principles. So, the first principles we know, its limit as x delta x tends to 0. The first thing we do is substitute x plus, we'll write the definition, f x plus delta x, then it could be x0 or f plus delta x minus fx over delta x. So, we know fx is x. So, we'll substitute that limit as delta x tends to 0, f instead of x we put x, substitute x plus delta x minus, this is fx is x, right, and divided by delta x. So, we see that x and x can be cancelled because it's positive and negative. So, we see that its limit delta x tends to 0, it is delta x over delta x, which is equal to 1. So, also we say the derivative is also known as dx or dy over dx, also known as dfx over dx. When f is equal to x, this is equal to 1. The derivative of the function fx or fx equals x or y is equal to 1. So, we write dy over dx when y is equal to x. I'll erase this part and start with dy equals with y equals x. When y is equal to x, dy over dx is equal to 1. Let's take another question shortly. Okay, for this question, they want you to find the slope or the derivative of fx 1 over x. So, y is equal to fx is equal to 1 over x, and we are asked to find dy over dx, and we know by definition it is when limit x tends to delta x tends to 0, it's f x plus delta x, a small value above x, and minus fx over delta x. So, what we do is we substitute x plus delta x and subtract x, the function x, and divide it by delta x. So, let's equate this to limit as delta x tends to 0, and we substitute 1 over x plus delta x. Maybe this is too close. Let me bring this down so that that won't be an interference. So, we do 1 over x plus delta x minus 1 over x over delta x. So, we take the common denominator here, limit as delta x tends to 0, we take x plus delta x times x, and here we get x minus x plus delta x, and the whole thing we divide it by delta x. So, the next thing we do is we simplify this further. So, we have limit as delta x tends to 0, we will get x in the numerator minus x, and then we have minus delta x, and in the denominator we can combine these. So, we have x squared plus delta x and whole thing multiplied by delta x. So, that's this delta x. So, we can cancel these off, and as x tends to 0, we get 1 over, we can also cancel, no, let me write one more step here. So as limit delta x tends to 0, we have minus delta x over delta x and x squared plus delta x times x, and bring it over here. So we can cancel out these two values. So we cancel out this and this. So when we get limit as delta x tends to 0, we get minus 1 over, as delta x tends to 0, this tends to 0, so we get minus 1 x squared. So in other words, we will write this again over here. When fx equals y equals 1 over x squared, 1 over x, let me erase this and write it again, 1 over x, dy over dx is equal to minus 1 over x squared. Is also noted, you should always note that this is also written as a derivative of f is written as f dash x. F dash of 1 over x is equal to minus 1 over x squared. Let's do one more question where we'll get the derivative from the first principles. So next we'll look at the derivative of a constant function. So if we have a function f(x) equals c, what is the derivative? What is the fx? How do we prove the find the fx from the principle of limits? So we say limit as delta x tends to 0. We have, what we do is we substitute x plus delta x for c and then subtract c again and divide it by delta x. So since the function does not have a x, so we cannot, I'll first write the definition, f x plus delta x minus fx over delta x. So since the function does not have an x here, we substitute only c. So we say limit as delta x tends to 0. We say fx plus delta x is c minus fx is c again over delta x, and as delta x tends to 0, the limit is 0. So in other words, when a function, let's say y equals fx equals a constant, c is a constant, y prime x or y dash x is equal to dy over dx is equal to 0. Let's look at another function. The next function we are going to look at is y equals fx equals 3x. So let's write the definition for a derivative. So we are asked to find dy over dx, which is the derivative, or is also known as f prime x of this function. So let's start from the first principles. We have limit as delta x tends to 0. We substitute for this x, we substitute x plus delta x, right? So we say 3 times x plus delta x, and we subtract the function minus 3x and divide it by delta x, and this is equal to limit as x delta x tends to 0. We get 3x plus 3 delta x minus 3x over delta x. So we have expanded this function, and we see that these values cancel off. So we see these cancel off, and we have limit delta x, as delta x tends to 0, we have 3 delta x over delta x, and we can cancel these off as well. They are common factors. So we have the answer would be 3. So for if y is equal to fx equals 3x, dy over dx is equal to f dash x or prime x or is equal to 3. So that's the answer. The derivative of y equals 3x is 3. So let's look at one more question, and we'll try to derive the derivative from first principles, where fx equals y equals x squared. We are asked to find f prime x or dy over dx, or it's also known as the derivative. So let's look at the function. A derivative is written as limit as delta x tends to 0. We substitute for x, we substitute x plus delta x, so we get x plus delta x squared minus the function x squared over delta x, and as delta x, and we'll expand this now. So we get limit as delta x tends to 0, we have x squared plus 2x delta x plus delta x squared minus x squared over delta x. So there are some common factors we can get rid of. This will cancel off. Then we have limit as delta x tends to 0. We have 2x delta x plus delta x squared over delta x. So we can, since delta x is common, we can take the delta x's out. We can cross off one delta x here. So we will have limit as delta x tends to 0. We have 2x, and this tends to 0. So that is the answer. So as delta x plus we have delta x, because there's one delta x remaining. So as delta x tends to 0, you get 2x. So if the function is y equals x squared, fx equals f prime x or dy over dx is equal to 2x. That's the derivative of x squared. Let's do one more question from basic principles. So let's derive the derivative of fx equals y 3x squared from the first principles. So if fx is equal to y is equal to 3x squared, f prime x is the derivative is equal to y prime is equal to, that's what we need to find. So that's what we need to find here, is also equal to dy over dx. Let's go through the first principles of a derivative. A derivative is equal to limit as x tends to delta x tends to 0. We have, first we substitute x plus delta x to the 2x, so it's be 3x plus delta x to the power 2, and minus, we just subtract this equation over delta x. So as delta x goes to 0, we can write it like this. So we will expand this. It would be x squared plus 2x delta x plus delta x squared minus, that's we have to multiply by minus 3x squared over delta x. So we see that we have a plus 3x squared. We'll expand this further to make that clear. Delta x tends to 0. Let me erase this extra line, and then we see it's 3x squared plus 6x delta x plus 3 delta x whole thing squared minus 3x squared over delta x. So we see that these can be crossed off, x squared, and this can be crossed off. We can cross off one of these and one of the squares off. So then we have limit as delta x tends to 0. We have 6x plus 3 delta x, 3 times delta x. As delta x tends to 0, we know that this goes to 0, so we are left with 6x. So we go back to this place where y is equal to 3x squared, y dash, y prime, or dy over dx, or f prime is equal to 6x. We have seen that when y is equal to x, dy over dx, let me write this again. We have seen that dy over dx is equal to 1. That's the derivative, is equal to 1. When y is equal to x squared, we have seen dy over dx is equal to 2x. So let's look at the power rule. So the power rule says, like, if you have a function f x to the power n, y equals x to the power n, then dy over dx, the derivative of that function, is equal to n x to the power n minus 1. So basically what you do here is multiply the n, and you get n, and you subtract 1 from the power of x. So you multiply and subtract 1. So they found this using the first principles of derivation, which is limit as delta x goes to 0, f x plus delta x minus fx over delta x. So they found this from these principles, but that is called a power rule. So let's see whether it works for this, our function that we found. So here the power of x is 1. So it looks like it is 1 times x. 1 minus 1 is 0. So x to the power 0 is 1. Therefore, this is correct. So here this is 2. So it's 2. 2 minus 1 is x. So that is 2x. That is correct. And this is 1. Because x to the power 0 is 1. X to the power 0. X to the power 0 is equal to 1. Let's see if it's true for this. Let's look at y equals x to the power 3. Then dy over dx is equal to 3x. You multiply this by 3 and subtract 1 from 3 is squared. We'll look at another function, 2. Y is equal to x to the power 4. Derivative dy over dx is equal to 4. You multiply this by 4. So this is n, right? 4 x to the power 3. You subtract 1 from this. Let me do another example. Example number 3. Y equals 2x to the power 4. Dy over dx is equal to, now you multiply this by this, it's 8 x to the power 3. 4 y equals 3 x to the power 5. dy over dx is equal to 15, because it's 5 times 3, 15. X, you subtract 1 from the power to the power 4. So remember, when you take the derivative, the power of the x goes down by 1, while you take that power and multiply it by the first value of the function. Let's look at another example. So here y is equal to x to the power 3. So dy over dx is equal to, you multiply this by the factor here, so it's 1, so it's 3x, 3 minus 1 is 2, so it's, the answer is 3x squared. So let's look at this. Dy, if this is y, dy over dx is equal to, you multiply the power of x, you take the power of x out here, 3, then we say x 2 over 3 minus 1. So we have to solve this. Next would be 2 over 3 x, you have 3 as the common denominator, then it's 2 minus 3. So it is 2 over 3 x to the power minus 1 over 3. Then let's look at this. So dy over dx is equal to x to the power square root of 2. So that can be written as we can write that as, I'll delete this for the time being, just a second, I'll erase this. So this can be written as square root of 2 x square root of 2 minus 1. That would be the power rule. So here we'll use dy over dx, we'll write x as y as x to the power minus 4. Then dy over dx is equal to minus 4 x to the power, so you subtract 1 from here, then you have minus 5. So that's the answer to that. So that will be minus 4 over x to the power 5. So we can take this, if y is equal to x to the power minus 3 over 4, then dy over dx is equal to minus 3 over 4 x minus 3 over 4 minus 1. So that would be minus 3 over 4 x to the power minus 3, 4 is the common denominator, and minus 4. So that would be 3 minus 3 over 4 x to the power minus 7 over 3. One more question. So here if y is equal to x squared plus pi to the power half, and that would be because this is similar, this is the same as this, so then y would be x 1 plus pi over 2. You taking this half into this part, then what you get here is the whole thing here is the power of x. So we do 1 plus pi over 2 x to the power 1 plus pi over 2 minus 1. So we get 1 plus pi over 2 x to the power pi over 2. Do more questions quickly. So using first principles of derivatives, it has been shown that derivative of is, say, if y is equal to c, which is a constant, and a function u, which is a function of x, fx, like x squared or x cubed, you can write the same thing. Let's say partial derivative, sorry, not partial derivative of d over x of cu, it can be written as c times du over dx. So if I replace u with fx, because it's a function of x, we can write d over dx c fx as c d of fx over dx. So let me take an example. Let's say fx is equal to x squared. What is 2x squared? If that would be, this would be 2 times fx. And if we take derivation d over dx of x squared, we get 2x. And if we take the derivative of d over dx of 2x squared, we get 4x. So this proves that derivative of 2x squared is equal to 2 times derivative of x squared. So next we'll discuss the derivative of sum rule. So this says if u and v are differentiable functions of x, then the sum of u and v is differentiable. So in other words, if let's say u is equal to fx and v is equal to gx, so then the derivative of fx plus gx is equal to the derivative of fx plus the derivative of gx. So if you have two functions, for example, if it's 2x plus 3x squared, so what you can do is get the derivative of this function and then add it to the derivative of this function. So if y is equal to this, then dx over dx of 2x plus 3x squared is equal to the derivative of 2x plus derivative of dx 3x squared. And this 3 can be taken out from the previous rule, so we can say d of dx, and the 2 can be taken out as well, x, because they are constants, plus 3 d over dx of x squared. So if you see that, you can see 2x derivative of x is 1, this is times 1 plus 3 times 2x. So it is 2 plus 6x. Okay, let's do one more question. So next we'll look at some elementary functions, function derivatives. So these we will just state the functions without deriving it from first principles. So let's say fx is equal to c. We have shown the derivative of this dc over dx is equal to 0 here. So we say that's first function. We have shown this from first principles. The second, fx is equal to x. Then d of dx of x is equal to 1. 3 fx equal to e to the power x. Now we have not done this before, but in this case we will have to remember this when we are solving problems. So there are some functions that it takes a long time to derive from first principles, so we generally try to remember this. So the derivative of e to the power x is equal to e to the power x. Same. And let's say function number 4, fx is equal to ln x. Then if we get the derivative of ln x is equal to 1 over x. So this, you need to remember this as well. And fifth function, fx equals sin x. And we'll look at the derivative of sin x. Derivative of sin x over dx is simply cos x. I'm not using first principles to show these, just stating some of the derivatives here. Then 6 fx equals cos x, and the derivative of cos x is equal to minus sin x. Remember that, it's minus sin x. Then finally fx equals tan x. Tan x is equal to derivative of tan x is secant squared x, which is also equal to 1 over cos squared x. So these are some functions you should remember, because this can come in some specific problems. Next we'll go through the product rule. So if u and v are differentiable functions at x, then we can get the product of uv. So product of uv, if there are two functions, for example, if it's 3x times sin x, two functions, we know the derivative of 3x and we know the derivative of sine by itself, but we don't know the derivative of 3x times sine. So they say if you get a function of this nature, you multiply u, this would be u, and multiplied by the derivative of sin x plus v, the derivative of u. So this also can be written as f of x, and this could be g of x. So we can see that the derivative of f of x times g of x is equal to f of x derivative of g of x plus g of x and derivative of f of x. So that's a rule we will apply to this function. So if we say derivative of 3x times sin x, where fx is 3x, gx is sin x, we write the first function the same, 3x, What's the derivative of sin x? We know that we just learned that it is cos x plus gx. So it is gx is sin x times derivative of 3x. We know it's 3. So that's using the product rule on this function, where it comprises of two functions, 3x and sin x. Let's look at another question. So let's do another example of to show the product rule. Let's say y is equal to e to the power x times 3x squared. So these are two functions. So the derivative of e to the power x times 3x squared is equal to, we write this function the same first, e to the power x, and then we differentiate d over dx of 3x squared. Then we just add 3x squared as it is and differentiate e to the power x. And we know the differentiation of this and this. So we say e to the power x, differentiation of this is, multiply this by this, so it's 6x plus 3x squared, and we know the differentiation of e to the power x is ex. Having said that, we will next look at different variations of the derivative of the function ex. So we know that the derivative of the function ex is ex, but also it could be shown that the derivative of the function c times ex is c times e to the power x. So it's cx. So if you multiply, this is similar to this being a function of x, and it's similar to d over dx of c times ex, which is a function of fx being equal to c d over dx of fx. So, and when fx is equal to ex, we see that it is cex. That's the derivative of d over dx of c fx. Let's look at one more example. So we just saw the derivative of the product rule. Now we are looking at the derivative of the quotient rule. So if there are functions one divided by the other, what happens? So what this says is, if u and v are functions of x and it's differentiable at x, then it is, we take the denominator and repeat the denominator, and then take the numerator, differentiate the numerator, and subtract the numerator and differentiate the denominator and square the denominator. That's what you do. So if, for example, if it's fx over gx, first write the denominator, differentiate the numerator, subtract the numerator differentiated by the denominator, and square the denominator without differentiating it, just square the denominator. So let's do an example along that line. So an example for this would be if y is equal to x squared over sin x. So here we see gx is sin x, so we just write sin x, differentiate f dash x, differentiation of this is 2x, minus, write this again, x squared, differentiation of sin x is cos x, we saw that previously, and simply to take the denominator and square it. So that's an example. I'll do another example. So here this is fx and gx. So the derivative of dy over dx is equal to, you first take the denominator and write the denominator, t cube plus 1 multiplied by the differentiation of the numerator, which is 2t. Then we get negative minus, then we write the whole numerator, which is t squared minus 1, and the differentiation of the denominator, which is 3t squared, over, you take the denominator and square it, t cube plus 1 and square. So if we simplify this further, we can multiply this. So we get 2t to the power 4 plus 2t minus, we'll multiply this, so it's 3t to the power 4 minus 3t squared over t cube plus 1 to the power 2. And you can further simplify it. So from here we get minus t to the power 4 plus 3t squared. So from this we get 3t squared plus 2t, and then we can also write this as t cubed plus 1 to the power 2. So that would be the answer. So if you look at this question, it looks like there is a product and a quotient. But before we do it as a product and as a product and as a division, let's first multiply this and see what happens. So if this is y, we can write this as x to the power cubed and minus 2x squared, and here minus x squared plus 2x, and divided by x to the power 4. So if you look at this, we see x squared, we can take the x to the power 3 out, and did we not do this correctly? This should be x to the power 3. X to the power 3. So it is x to the power 3 minus 3x squared plus 2x. So because you add these through, 2 you get x squared, and then you divide it by x to the power 4. So then we can go and divide each individual value by x to the power 4. So we get 1 over x minus 3 over x squared plus 2 over x cubed. Then we can bring all the x terms to the numerator and say x to the power minus 1 minus 3 x to the power minus 2 plus 2 x to the power minus 3. And now it's very easy to differentiate this. This is minus x to the power minus 2. Here we multiply this by minus 2 by 3 is plus 6. X to the power, we subtract the 1 from this power, so we get 3 plus, it should be minus, because 3 times 2 is 6, x to the power minus 4. So in other words, we get minus 1 over x squared plus 6 over x cubed minus 6 over x to the power 4. Let's do a few more examples. If y is equal to x squared minus sin x, dy over dx is equal to, this is 2x. When you differentiate this function, you get 2x, and minus sin x. When you differentiate sin x, you get cos x. Then this is a product rule. So for the product rule, we use dy over dx, and what we do here is we write ex as it is, and we differentiate over dx of sine x and add to that sine x and differentiation of ex. So we can start from here. So e to the power x, we have e to the power x. Differentiation for sine x is cos x. Plus we write sine x. And differentiation of ex is, we know it's just ex. That's the answer to that. So let's rewrite this here so that we'll have enough room. Y equals sine x over x. So what we do here is we first start with the denominator. This is the quotient rule. So we start from the denominator. So we say x times differentiation of the numerator sine x, and this negative. Then we say sine x, that's the numerator, and differentiation of x over x squared. So we know this is 1, so we'll write x times differentiation of sine x is cos x minus sine x. Differentiation of x is 1 over x squared. So that's the answer for that. We'll do a few more questions. So this is a sum of two functions. So it's dy over dx, and we know this is a constant. We can take that out, e to the power x over dx plus d over dx of cos x. So that is, we know the function here is ex. When you differentiate ex, you still get ex, plus we know the differentiation of cos x is minus sine x. And this is a product rule. So dy over dx, we use the product rule because this is one function and another function. So first we keep the sine x the same, x, and multiply by the differentiation of cos x, and add cos x by the differentiation of sine x. So we have sine x, and the differentiation of cos x is minus sine x. So we have sine x multiplied by minus sine x plus cos x multiplied by cos x. So we have cos squared x minus sine squared x. This part is here, and I put that there. Let's do a few more questions. So this is quotient rule. We have to use the quotient rule. So we have a function in the numerator and function in the denominator. We know dy over dx is, we take the denominator first, we multiply 1 minus sine x by the differentiation of cos x, and then subtract cos x by the, and we multiplied by the differentiation of 1 minus sine x, and we square the 1 minus sine x square of that. So we'll write the denominator the same, 1 minus sine x squared, and we write this the same as well, 1 minus sine x, and and we know the differentiation of cos x is minus sin x. Then we have cos x, and the differentiation of 1 is 0, and we have 0 minus differentiation of sin x is cos x. So we have here, we multiply this, we get minus sin x, and we have plus sin squared x, plus this is 0 plus cos squared x. Let's see, yes, that is true. Over 1 minus sin x whole thing squared. And we know, on a side note, I'll say sin squared x, sin x squared let me redraw that. That's correct. Sin x squared plus cos squared x is equal to 1. So when you substitute that here, we get 1 minus sin x over 1 minus sin x squared. Conveniently, we can cross off this 1 minus sin x with this, the extra 1 minus sin x. So we have 1 over 1 minus sin x. Do a few more questions. So here I'll do a few questions from chapter 3, exercise 3.3. So if y, the second question is, if y is equal to x squared plus x plus 8, what is the derivative? Dy over dx is equal to, we know this from the power rule, it's 2x plus 1. And the constant, when you do the derivative of a constant, that's 0. Let me do 4. Question number 4. W is equal to 3z7 minus 7z to the power 3 plus 21z to the power 2. So we multiply the power by the constant here, so it's 21, and we subtract 1 of this, so we got 6 minus, we again get 21 z to the power 2 plus this is 42 z to the power 1. Let's do 6. Y equals x to the power 3 over 3 plus x to the power squared over 2 plus e to the power minus x. So dy over dx is equal to, now what we do is we multiply power, we use the power rule here. So we do 3x squared, we subtract 1, divide by this 3 plus 2x divided by 2 plus e to the power minus x. So now this should be, now it has a constant, so you have to multiply that constant here by this function. So we say minus 1. So we cross off the common terms. So we have x to the power x squared plus x minus e to the power minus x. Do the other questions on another slide. Question number 8. S equals minus 2t to the power minus 1 plus 4 over t squared. So let's get the denominator to the numerator before we work with this. So it's minus 2t minus 1 plus 4t minus 2. So we do ds over dt is equal to 2, you multiply this by 2, t minus 2 plus 4 times 2 minus 2 is minus 8t, and we subtract 1, so 2 minus 1 is minus 3. So if you write it out well, we'll see t2 over t squared minus 8 over t to the power 3. So let's do number 10. Y equals 4 minus 2x minus x to the power minus 3. So dy over dx is, we know if it's a constant, is 0. So it's minus 2. Then we multiply this by this, we get plus 3 x to the power minus 4. We subtract 1. So we get, this is the answer for 10. So 12, r equals 12 over theta minus 4 over theta plus 1 over t to the power theta power 4. Let's take all the denominators to the numerator. So we get r equals 12 theta to the power minus 1 minus 4 theta to the power minus 3 plus 1 theta to the power minus 4. So dr over dt is equal to minus 12 theta, and you subtract 1, so it becomes minus 2. Then we multiply this by this, we get minus plus 12 theta to the minus 4 minus 4 theta to the power minus 5. So we'll rewrite this. So we have minus 12 over theta squared plus 12 over theta to the power 4 minus 4 over theta to the power 5. So I would encourage you to finish chapter 3, 3.3, and if you have any questions, there are about 25 questions in that. Please complete those, and if you have any questions and if you want me to do any of those, please comment below.